Hi and welcome to the OneClass channel. My name is Shenaeze and I'm a second year student at McMaster University. I'm currently in the life science program doing a minor in environmental science. Today we're going to be solving some mathematical and pre-algebra and algebra questions. So if you guys want some homework help or tutoring, please feel free to check out the link in the description below and let's get started. So our first question is, what are conjugates in math? So, one, in math. So conjugates are mainly just used in binomials, and they are kind of like the opposite, are the different operators in between of the two terms. So for example, if we have an equation as x plus 3, right? Its conjugate is going to be, so the operation, that is what's going to change. It's going to turn into the opposite. So the opposite of addition is subtraction, and the opposite of subtraction is addition. So this is going to turn into x minus 3. So that is its conjugate. Another example could be plus 3. Same thing, we're going to take the term over here and think of its conjugate and keep everything else the same. So the conjugate for that would be square root of x minus 3. That's its conjugate. We could do an example where we are given, for example, let's do a harder one. So square root of x plus 1 minus 2. This conjugate, a lot of people, they might confuse this and turn that into negative. That is one of the biggest problems because you have to look at between the two terms. This is your first term, this is your second term, and the operator between that gets shifted. So this is just going to be x plus 1 plus 2. That's its conjugate. Conjugates are also normally used in like difference of two binomials or perfect squares. So an example of that could be over here. So we have x squared minus 4. This is the same as x minus 2 and its conjugate, which is x plus 2. So when you multiply it throughout using the FOIL method, you're going to end up with the same answer as that. Conjugates are also used for rationalizing expressions. So, for example, if you're given a question or 2 over the square root of x plus 1, and you need to find out, you have to rationalize it, because you can't have a square root in your denominator. What you do is you multiply it by the denominator's conjugate. So this, the conjugate, will be square root of x minus 1 over the square root of x minus 1. Because when you divide these out, that equals, if you divide them out, they equal to 1. So you're not really doing anything to the function. However, you're just rationalizing it, making it better. So when you multiply that out, that becomes 2 times square root of x minus 2 over x minus, you can square root plus the square root of x minus 1. These two get canceled out, and you're left with 2 square root of x minus 2 over x minus 1. You can take out the 2 if you want. You can leave it in. It's up to you. Square root of x minus 1 over x minus 1. So there you go. Our next question is factor x squared minus 1. So we're going to be using the FOIL method. If you guys don't know what that is, FOIL. So the F stands for first term. Oh, sorry. I thought I was remultiplying it. It says factor, not simplify. Anyway, so here what we can do, we just learned about conjugates. We can apply that to our function over here. And we know that x plus 1 times x minus 1 it's a conjugate. So you can also multiply it out to see if it equals to x squared minus 1, and it will equal to that. Okay. Next question, we're going to be using what is bracket 3 times 8 minus 2 plus the bracket 3 plus 6. And that is our question. We're going to be following BEDMAS, if you guys, BEDMAS. So B stands for brackets. E stands for exponents. D stands for division. M stands for multiplication. A is addition, or you add, and S is subtraction, or subtract. Okay. So over here we have two brackets. So we're going to solve them together. 8 times 3 is 24 minus, if you want you can leave it in the bracket, 2 plus the bracket, 6 plus 3 is 9. Next, so over here we followed BEDMAS because we had brackets. We don't have exponents, we don't have anything left to divide, we don't have anything left to add. Multiply. But we have addition and subtraction. So first we're going to add, because addition is first. So 9 plus 2, 24 bracket, minus 9 plus 2 is 11. And then we are left, and then we are left with that. So subtraction comes after. We are left with 13. So in this case, I'm sorry. I messed up here. So we're gonna add first. Minus. So we're gonna add these two terms first because they have the addition. So that would be 33 minus 2. And then we can minus, and it'll be 31. Which statement describes the graph of this? So what we can do, I'll just write that down. Then I'll pull up Desmo so we can graph it. 3 f of x is equals to negative 4x cubed minus 28x squared minus 32x plus 64. And that is our equation. There are two ways to solving this. The first one is putting it in or graphing it or putting it into a graphic calculator. So we're just going to do that. Is equals to negative 4x power of 3 minus 28x to the power of 2. Sorry. And then we're going to minus 32x plus 64. So we're going to get a function like that. I'm just going to zoom out. Like this. Now, the question is, which statement describes the graph? So the graph crosses the x-axis at negative 4 and touches the x-axis at 1. So here, so it basically is just asking us for when it crosses the x-axis and when it touches the x-axis. So when we look over here, when it touches the x-axis, over here it's negative 4, and when it and when it crosses it completely, it's at 1. So we're looking for x. Crosses the x-axis at negative 4 and the x-axis at 1. So the answer would be A. Same thing over here. They've just graphed it. Another way of how we can figure it out is by using, by substituting in the values. So whenever we can take each value, so we can take negative 4 and plug it in for our x, and we can take 1 and plug it in for our x. The same with the second option. We can take negative 3 and plug it into our equation. What we're trying to find is what number, when we plug it in for x, equals 0. So for the graphing method is a lot easier because it tells us straight away, but we can also do substitution, and we'll start with the first option. So if we substitute, let's say 1 into the equation, we get negative 4 times 1 cubed minus 28 1 squared minus 32 times 1 plus 64. So this essentially just becomes negative 32 equals 64. So negative 64 plus 64, and that equals 0. So we know that that is correct. So x at 1 would be a 0 on the graph. Our second one, just to confirm, is negative 4. So when we plug in negative 4 cubed minus 28 negative 4 squared minus 32 negative 4 plus 64. So when you plug this in your calculator, you're going to get 0 as your answer, and that's when you know that x at negative 4 is another x-intercept, or x0. Our next question asks us, how do you simplify x plus 5 squared? So, for x plus 5 squared, we're going to be using the FOIL method. For those of you who don't know what the FOIL method is, F stands for first, or first term. O stands for outer term. I stands for inner. And L stands for last. This is the same as writing down x plus 5 times x plus 5. So first we're going to multiply that, and then we're going to multiply this, and that, and this. So x times x is x squared, and x times 5 is 5x. Move on to the next term. So 5 times x is 5x, and 5 times 5 is 25. So this equals to x squared plus 10x plus 25. And that is our final answer. Right there. You can also use this method, just keep this in mind, is a plus b squared is equals to a squared plus 2ab plus b squared. Next question they ask us is, what is a second degree polynomial? So the degree of a polynomial is like the highest exponent on any of the variable, any of the thing in the equation. So what is second degree polynomial? So a second degree polynomial, we can say that, for example, x squared plus 2 is a second degree polynomial. A first degree polynomial would be, exponent would be 1. So a first degree one is maybe like x plus 1, because we know the exponent over here is 1. Our second degree would be something like x squared plus 1, because our exponent is 2. Our third degree would be x cubed, or x to the power 3 plus 1. An example over here that they've given us we can do is x squared plus 2x plus 9 is equals to y. That is an example. Another example could be, I don't know, f of x is equals to 5x squared plus 9. Or as simple as f of x is equals to x squared. Those are all second degree polynomials. The next question is, how do you simplify 1 over x to the negative 2? Now, something that we need to know when solving this question is that m is equals to 1 over m to the negative exponent, to the negative n. Okay, so that's the law of exponents. Law of exponents is that. So for example, if you have like a 2 here, that would be 1 over 2 to the negative 1. Okay. So over here, our question is 1 over x squared. 1 over x to the power of negative 2. So when you flip or when you solve for it, it gives you, so you take it from the denominator, you take it to the numerator, right? Using this, using this law of exponents, this would equal x to the power of 2, right there. Another example we can do is 1 over x negative 3. This would equal x to the power of 3, or x cubed. Okay. Our next question over here is the vertex and axis of symmetry. Vertex and axis of symmetry. I'm just going to draw a graph over here, kind of like point out of where it's going changes. So over here, as you can see, it is decreasing on this side, and then it changes to increasing on this side. So that is your vertex. The axis of symmetry is a line that kind of divides your function into half, right there. Actually, I'll see if I can make it better. So that right there is your axis of symmetry. Now how you calculate them is, so the equation for the axis of symmetry Let's see. That is your vertex. So the equation for the axis of symmetry is h is equals to negative b over 2a. So you're going to take your equation, which is in standard form, right here. So f of x, or y, is equals to ax squared plus bx plus c. So the value a and the value b, right there, you're going to use that in your axis of symmetry. Now, the vertex of a quadratic function, vertex, is defined as h and k. So the same h over here, because the axis of symmetry is at the same point as your vertex, but the x coordinate of it, because that's your x plane right there, it's your y plane. So the values are going to be the same. How you can calculate the vertex, there are a bunch of different ways, but mainly if you know the h of the equation, you can just plug the value in and isolate for k, or you can find out both of the x's of your quadratic function by using the quadratic formula and then dividing them by 2 to figure out the x coordinate of the vertex, and then again plug it in and find out the value for k. Okay. So for this question, solution. So if you guys don't remember what a discriminant is, I'm just going to write down the question first. What is the discriminant of the equation 3x squared plus 6x is equals to 2? How we can figure that out is by using v squared minus 4ac. Now if our value is a positive number, so above 0 or greater than 0, then we have there are two real roots and they're equal, and if we get our value of bx minus 4ac is less than 0, so, or a negative value, then we get no real roots. Okay? And lastly, if we get b squared minus 4ac is equals to 1, then we have one real equal root. So we can use that in our equation over here. We are given that number right there. So 3x squared, we bring 2 over to one side, plus 6x minus 2 is equals to 0. So b squared minus 4ac. Our b value is 6, so 6 squared minus 4 of a is 3, and c is -2. So the square root of 6 is 36, minus 4 times 3 is 12, times 2 is 24, negative negative cancel out, that becomes a positive, 24. And when you add them together, they equal 60. So our discriminant is 60, and it also, which is the D, which also tells us that it's a positive and will have one root. Question 8, I believe. How do you solve P is equals to 2L plus 2W? So basically for W, they're basically asking you to just isolate for W. And how you can do that is using simple algebra. So the first thing you're going to do is get rid of this term over here. You can do that by minusing 2L on each side. So P minus 2L is equals to 2L plus 2W, minusing 2L, which will get rid of this for us. That gives us P minus 2L is equals to 2W. The next thing we have to do is get rid of the 2 in front of the W. We can do that by dividing each side by 2. So here, we get rid of that, and we're left with W alone. So W is equals to P over 2L over 2. And that is our final answer. Right there. Our next question asks us to simplify 5 over 10. Now, we can do this by reducing it to its to the lowest form. So 5 over 10. Think of a number that you can divide both, because whatever you do to the denominator, you have to do to the numerator. So if you multiply the numerator by a certain amount of number, you have to multiply the denominator by the certain amount of number. And if you multiply the denominator by a number, you have to multiply the numerator by the same number. So 5 and 10, the common factors, you can think of 5. The factors of 5 are 1 and 5, and the factors for 10 are 1, 2, 5, and 10. So the common ones that they have is 1 and 5. So if we divide by 1, we're going to end up with the same answer, 5 over 10. So now we have to divide by 5. So if we divide this by 5 and divide this by 5, we are left with 5 divided by 5 is 1, and 10 divided by 5 is 2. So we can write that as 5 over 10 is the same as 1 over 2, but simplified. And that is our final answer. Those are all the questions that we had for today. This was Shenaeze from OneClass. If you guys have any more questions or want to send in some of your own questions, check our links out in the description below, and make sure to like and follow and subscribe to our channel and turn on your notification so whenever we post a video you guys are notified. And yeah, this is Shenaeze from OneClass.